Let's start at the very beginning.
Mhm.
Okay, here we go. All set?
Yes, good to go.
Okay, wonderful. Thank you for the introduction, Mr. Chair. So let me quickly introduce myself. I'm a lecturer in the Department of Civil and Environmental Engineering at the University of Waterloo, where I recently joined 2 years ago, having completed a postdoctoral degree at the University of Toronto, which is where I obtained all my degrees, and which was where I focused on Africa for a lot of the work that I did. So in this presentation, I also tried to dig up some of the research, some of the findings that came out of that study to give a little bit of an African focus as well to some of what I'm presenting today. So the title of my talk is Urban Metabolism to Demonstrate Material and Energy Flows in Cities. And I'm gonna sort of zoom out a little to look at cities. So my area of specialization is sustainable cities, which includes all the building blocks that make cities. That's the buildings, the transportation, the energy, the water, the green space. So in this talk, I'll just take you on a tour around the world to see how urban metabolism is demonstrated. Okay. Because this session also includes a focus on climate change, I thought I'd start with this, which is the memorial that was placed in Iceland towards the end of 2019. And it's a memorial to a lost glacier, and it had a striking message for the future. And the message is, Oak is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it. And this is a message for the future signed in August 2019. And the parts per million right now registering then is 415. And so it's kind of futuristic, future looking, but we've got a lot that can happen today. And the adage of what gets measured gets managed is what should drive a lot of our sustainability action today. So let me first make the case for cities. So my starting point is the urbanization and the resulting rapid population growth that's happening in cities, where cities are home to over 50% of the world's population, and that's expected to increase to 70% by 2050. Now, comparing that growth, we're actually looking to see an additional 2 billion people added to our planet. That 2 billion is estimated to be, the majority of them will be on the African continent. And that's approximately an additional 3 billion by 2050. So it was around 2010 where the population of the urban environment actually exceeded the rural population. So there's a lot of us that actually live in cities, therefore have a responsibility and an obligation to take action as well, because we are the major contributors to all the challenges, particularly the climate change challenges. Okay. Now, I want to take that as a basis and make the case for Africa. Our work on the African continent was really looking at the urbanization in Africa. And our study of the population growth estimates that by the year 2100, so by the end of this century, African cities will make up 5 of the top 10 and 13 of the top 20 most populated cities in the world, where Lagos will sit at the #1 spot with 88 million people. So I set the stage with that kind of population growth to try to imagine or visualize to what extent are the challenges evident today and how much more will be present with that much increase of population and all the services and provisions that need to be provided to accommodate this growth in population. So this is part of the postdoctoral work, which I completed in 2018. It took us to 12 different countries in Africa. This orange spot over here is actually not a mistake. It's in Mauritius, and there was a lot of visits to higher education institutions in Africa to see how could the civil engineering curriculum really be tailored to have a more focus more broadly on cities and not a very siloed approach to civil engineering, so that the engineering graduates of African institutions can really have the knowledge to be able to contribute in the economies that will be absorbing them on the African continent. So with population growth comes energy use. And the statistic here is that a near doubling of the energy demand is estimated since the 1980s, and that also is going to be rising an additional 85% by 2050. With energy use comes greenhouse gas emissions, especially if it's fossil fuel based. But in this chart, I want to make the case because with population growth, if we plot the rural population in green and the urban population in blue, the energy use, which is the red line, closely correlates with the urban population. So it is in cities that the fight for climate change will be won or lost, because it is in cities where climate change is being contributed by all the urban residents, but also it presents an opportunity in the driving forces behind finding the climate action and addressing climate change. So greenhouse gas emissions, again, all the statistics are on the rise. This one here shows that cities account for 70% of global emissions, and that too is expected to increase to 76% by 2030 if we continue to live and behave at current urbanization and economic growth trends. Now, the case for greenhouse gas emissions is very different and it's unequally distributed, and I make the case for Africa here because if you look at the tail end of this x-axis, you'll see that the countries that are listed here on the low income scale present some of the African countries. So you can see Ethiopia, you can see Tanzania, you can see Sudan and Nigeria. And the message here is that greenhouse gas emissions are unequally distributed. The African countries on a per capita basis are contributing the least to global emissions, yet they also have a huge responsibility because of the growth that's expected. So there's a huge opportunity for the African continent to leapfrog to more renewable rather than behaving the way the global north or the West had industrialized and modernized. In a study that I did with my colleagues in 2014 to look at 22 global cities and to really look at greenhouse gas emissions from the urbanized environment and to see how are they really divided in terms of the greenhouse gas emission sectors that include electricity, heating and industrial fuels, transportation, waste, and marine and aviation as well. And we plotted it here and divided it continentally to see to what extent every continent is really contributing. And you can see here, Africa at the very top, represented by Dar es Salaam and Cape Town, contribute very little together with South America in comparison to Asia, Africa, North America, and Europe. So when looking at these greenhouse gas emissions numbers, it's the story behind the activities that go on in cities that really tell a story about these emissions. So taking these greenhouse gas emission numbers with a grain of salt, but also recognizing that it's all contextualized to tell us and show us what's going on in these cities. So measuring sustainability is a tool so that we have quantitative and we've got numbers to support all the evidence-based policymaking that is possible. One of the tools that we're all familiar with is perhaps the Sustainable Development Goals with the quantified targets to be achieved and by a certain timeline. So it's the beginning of quantifying our targets. My particular focus is on SDG 11, which is the Sustainable Cities and Communities in making cities and human settlements inclusive, safe, resilient, and sustainable. But because it's so broad of a goal and it includes global cities, how do we actually go about doing that? And so I use urban metabolism as a tool, and I know it's been mentioned a few times throughout the day today. Urban metabolism is an analogy to human metabolism in that we have inputs and produce outputs. Similar to using that definition as it applies to cities, it is the sum total of the technical and socioeconomic processes that occur in cities, resulting in growth, production of energy, and elimination of waste. And to give you a quick overview of the origins of urban metabolism, it was as early as the 1960s by Abel Woolman, was a professor at Johns Hopkins with a focus on sanitary engineering, and it was motivated by his concern about air and water pollution and his desire to quantify the amount of pollution. And that was what helped birth the idea of that urban metabolism concept. So what he did was come up with the first urban metabolism study. And he used a hypothetical American city with a population of 1 million and used that urban metabolism tool to model and determine what kind of inflows come into the city to support services like water and energy and food, and what kind of outputs come out. The difference between the inputs and outputs is what remain as accumulated waste in the cities. So here's the results of the first urban metabolism study of that 1 million people in the hypothetical American city. You'll see here that all the units are in tons per day, representing the water inputs or inflows, the food, and the different kinds of fuel, all fossil fuels at the moment: coal, oil, natural gas, and motor fuels. Now, these inflows support services in cities and produce outflows. And these are represented in terms of sewage, with a percentage of suspended solids, in addition to refuse, and a lot of air pollutants that are also being trapped. Now, if we look at inflows and outflows, and you've probably seen variations of this diagram because it has been the focus of this session and conference. Inflows into cities and so inputs and outputs. This is characterized as a very linear metabolism, and it is a typical urban world process, which could be improved. So in trying to convert nature into society and assimilate with nature and have more sustainable activities and processes in cities, Herbert Girardet, an ecologist who came up with an industrial ecology approach in the mid-1990s, and he was a consultant to several UN organizations. But some of the books point to incorporating the natural element and the human element, such as including cities and people. So we're not just tracking material and energy, but we're also adding to it an environmental component. And this is what brings into focus a circular metabolism at the city scale. So in the circular cycle, there's nearly no waste and almost everything is reused. So it mimics a natural world process. So you'll see here the inputs become a little smaller. The outputs is a very tiny arrow because everything that is within the city continues to be reused to create that circular cycle. And if we look at cities generally, and if we look at the world at large, the world is 8% circular. So there's a lot that could be done in the circularity of the activities within cities. Material flow analysis is the tool that is used to, like an inventory approach of conducting an urban metabolism study. So the approach that I follow is one that was put together by Vicini and Brunner. And a material flow analysis is a way to measure the materials flowing into a system. It's the stocks and the flows within it, and the resulting outputs from a system into another system in the form of pollution or waste. And in an urban design context, so kind of zooming out at the city scale, it shows relevant processes and flows of resources for a component of the urban metabolism. It quantifies these stocks and flows of resources, including recycling, as well as quantifying the absolute flows across these system boundaries. System boundaries when it comes to cities is not as easy to identify as system boundaries when it comes to a country because borders are pretty clear. Cities is a little bit more fuzzy, but jurisdictional boundaries could be considered as a valid border. So the 4 key resources that are tracked in material flow analysis typically are energy, water, materials, and nutrients. In the extended metabolism model, here's where what is being tracked is not just these 4, but rather the bringing in some human element. So you'll see here, in addition to resource inputs and waste outputs, which is a typical material flow analysis, here's a little bit on cultural priorities, economic priorities, or transportation priorities. And from a livability perspective, there's a lot of other socioeconomic indicators or metrics around health, education, income, etc. They're less easier to quantify because some are quite intangible. It's often easier to quantify what we can actually see and measure and weigh. So I want to share with you a few examples from earlier studies of urban metabolism. Here's one in Miami, and the details are less important, but I'll point to some interesting points here on this chart. In Miami, because it was in the 1970s, it was important to look at energies. When the researchers tried to map this out, they also looked at energy and goods. And over here, tracking the money as a proxy to other activities, economic growth activities happening in cities. And you'll see here some of the outputs that are produced at the bottom here, air pollutants and waste, and wastewaters to the ocean. Another example is in Paris. So in 19th century Paris, a very simplified urban metabolism diagram here. What I want to highlight is you'll notice there's some energy, wind and sun, and then there's some inputs, but I want to focus on this one here is horses. And horses actually represent transportation in 19th century Paris. So there is an element of trying to track the building infrastructure, the transportation infrastructure, in addition to others. And then in Tokyo, quite a simplified diagram, but it still shows the inputs, shows the outputs, and what remains within the city are accumulated deposits and waste, which is in a circular cycle. We try to minimize what is accumulating within the city. And then Brussels is probably the most popular one because of the level of detail and because of the quantification of greenhouse gas emissions. So this is where not only is the energy tracked, but also based on emission factors, greenhouse gas emissions are mapped as well. And then lastly, one more from Hong Kong. Hong Kong, because of it being a manufacturing and a port city, there's a lot that that is being tracked here in terms of materials and waste. And of course, the water that is used in these manufacturing processes as well. So part of my work as an educator also tries to influence some of the thinking that we have in our department and what we are able to influence, particularly on the African continent when looking at engineering education curricula. So this book here was published by the World Watch Institute, where we were asked to look at changes or kind of reimagining the engineering education for the Anthropocene. So this is zooming way out. And we had one chapter in there with a focus on Africa to see what is it going to take to reimagine civil engineering, in particular, education that supports the built environment. So I asked my students, and I'm sharing this with you in the hopes that maybe it would inspire changing or influencing thinking at the undergraduate level. I tasked them with picking a city of their choice, looking at the populations today, projecting it out to the future, be it 2030 or 2050 and beyond, and trying to look at sources of data, databases that are available to them, and to try to quantify the energy, water, materials, and nutrients coming into a city, and the resulting air emissions, wastewater, and waste coming out of a city. And trying to see the differences in the two numbers is really the challenge of what needs to take place within the borders of the city. So trying to reduce what's on the input side, trying to reuse what's on the output side, and trying to introduce efficient processes and sustainability within activities in the city. So that's trying to create the objectives for each of inputs, outputs, and urban activities within. So these are some urban metabolism studies produced by students. I'll share some ones that are actually research related, but these ones are undergraduate students attempting to take a city of their choice. And I dug up one for Dar es Salaam to represent sort of the African continent and looking to see the magnitude of these numbers. You'll see here the sectors of cities that are of interest to them, but also following the greenhouse gas inventory approach. Here's Rio de Janeiro. And the idea here is that everybody does it differently. There is still no consistent way in doing it, but the greenhouse gas emissions inventory and the GHG global protocol is a way to make sure that we have a standardized approach to doing it, which leverages transparency so that when we compare cities to one another to be able to leverage best practices from one another, we can actually do that. And here's one from Kuala Lumpur. and I think this is the last one from Atlanta, and just trying to give you a different perspective from different cities around the world. Now, it's easy for students to actually quantify weight, so things that are measured in tons. It's very difficult to actually visualize tons of CO2. So this is actually, and it's good for everybody to know that a 1 ton of carbon dioxide is actually a cube that measures 8 meters on every side. And it was an art installation at the UN FCCC Climate Convention in Copenhagen. And so it helps visualize the magnitude of greenhouse gas emissions. So borrowing data that we had access to closer to home from Kitchener and the Waterloo area is a study that was recently published. Actually, the date here is 2021. And so this is as recent as last Thursday. Looking at the weight of cities. So this is not necessarily looking at the inputs and outputs, but rather looking at the stocks of both 2 sectors in the city. One is buildings and the other is transportation, to see how much of material do we actually have sitting in our building and road stocks in Kitchener and Waterloo area. And the color shading in the different areas in the city represent the material intensities of building and road materials. So just to give you a breakdown in terms of construction material, this includes concrete and wood, brick and gypsum, aggregates, asphalt and steel. And a building could be broken down even further, but the databases that exist at the municipal level is only able to capture these, with hope that we could potentially capture a lot more of the insides of buildings and what is within our walls, like different kinds of pipings, etc. So there's a lot more that can be done, and a lot more that can be done in terms of capturing the weight of the material underground as well, so the underground infrastructure. When it comes to roads, this is also the Kitchener and the Waterloo area, and the color, the widths of the lines represent material intensities. So these are highways, roads, arterial roads, and collectors with different material intensities depending on the type of road. And the materials that are tracked here are the material used in roads and sidewalks, but also virgin materials that are used for maintenance activities, in addition to a provision that is allowed in the maintenance of roads that includes a tiny fraction of recycled materials that could be used for maintenance activities in the road segments. Weight of cities is a new and evolving concept when it comes to cities. It was developed by the UN and World Bank. And we use this number and put it in contrast to some of the other countries and cities around the world to put it in perspective. So Kitchener and Waterloo, in terms of the total weight of the materials in the cities, fares it correlates quite nicely with the per capita material use as well in the cities around the world. There's lots more that can be done. This is the beginning of the work that has been captured in literature, and we add Kitchener and Waterloo to that list. So having shared some of the quantification, the key message here is that better data drives better action and also guides better policy making. So I kind of put a sustainability lens when looking at all the sustainability activities and potential that could take place in cities to drive and meet these sustainability targets and these climate targets as well. So I'll end with this slide and invite any questions. I'm happy to take. I haven't seen those that have been coming in the chat, but I'll unshare my screen and be able to see that. Thank you very much for your attention. Oh, I'm sorry, I can't hear you. Could you unmute?
Yes, I said that was a nice presentation. Yes, we have a number of questions for you. There is a question here that the concept of urban metabolism is likened to the system of the body of human being. And the details it looked like more complex. And how can urban metabolism observations be converted into tangible, helpful, non-academic tools for decision makers?
I think it's a very good question. It points to the challenges with data, and there is innovation on the data side as well, not just for cities, but across many other disciplines. I think at the academic level, starting off with building an awareness for the need of that data and the search for data. Every undergrad and every researcher knows they can have good research if they have good data. And so having gone through the Kitchener and Waterloo study is an example of how difficult it is to get the data. But even when the data is obtained, there's a lot of stitching of different data sets. There's a lot of cleaning up. Different data sets would classify buildings into 4 categories, or obtaining it from a construction association would classify it into 7 categories. Now you got to marry the 2 together to come up with some meaningful information, GIS as well. So for decision makers, I think to gain the trust of the decision makers to be able to use these numbers that we're coming up with to support any of the policy making that they do, I think we need to have faith in these numbers that we're collecting and use that as a baseline. So I think that because there's a lot that can be done, I think we need to establish a baseline first to be that starting point. And I don't think we're there yet. There are many efforts in standardizing, in coming up with a single approach to do data collection or data reporting. But I think if we want cities to be learning from one another to expedite that action towards sustainability or sustainable action, I think we need to be able to borrow each other's best practices and learn from one another.
So thank you, Nadine. If there are other questions, you can always attend to them because the time we are really running against the time. So thank you. That was a very good presentation.